Myself, Anvesh, Michael, Nikhil, and Thais, part of Team 7, are going to take you on a deep dive into Project SpaCy. But first, a short video about its use case. So, as is often the case, successful products start with simple ideas. As a postdoc working in a related field, Matthew Hornible, the founder of SpaCy, observed that it was notoriously hard and difficult to deploy NLP based products without having extensive resources like heavy compute and processing ability. He saw a space, pun intended, that could be filled with a library like SpaCy for fellow NLP enthusiasts to better realize their product vision. Today, SpaCy is a leading edge free and open source library for advanced NLP. Written in Python and Python, it is built for fast deployment and production use. It is one of the fastest syntactic parsers available and it's maintained publicly on GitHub by Explosion AI. SpaCy is dubbed as the NumPy of NLP, which according to us is quite high praise. So, what is SpaCy? But more importantly, what it isn't. It's really crucial to clear this air as there are quite few libraries that are working in a similar space. But SpaCy at its core is uniquely built for writing production level code, providing highly optimized pre trained models. Which brings us to a detailed comparison based on clear consumer requirements. As mentioned previously, while SpaCy strives to offer the latest and greatest in terms of state of the art models, that is not its main intention. Presenting the context view, let me walk you through what we haven't yet discussed. Since it's a library, SpaCy is platform independent. Additionally, there are new products being built on top of SpaCy like Think and Sense2Vec, which we'll come to at a later point in the presentation. From an architect's perspective, it is quite interesting to see that at this point in its development, SpaCy is quite driven by its community. Taking an in depth look into the SpaCy repository, we can see that the team maintains a close contact with all its stakeholders and they encourage active contributions and have clear directions for collaboration in terms of bug fixing, enhancements, etc., which are all seriously appreciated. Now, over to Thais for a peek under the hood.
Thanks for the floor. In this slide, the system decomposition of SpaCy can be seen. We use the secret tool to create this decomposition. One thing that can be seen is that the lang module is the biggest, which is logical due to SpaCy being a multiple language supporting processing tool. In order to process a given text, SpaCy uses a basic pipeline of four main components, namely the tokenizer, tagger, parser, and the named entity recognizer, or NAR for short. However, on top of these basic pipeline components, custom components can be added. Also, from SpaCy version 2 onward, the statistical components, like the tagger and parser, do not depend on each other anymore, which means they can be switched around or even totally removed from the pipeline when custom components do not depend on them. Tokenization is one of the most used functions of SpaCy. Whenever a text has to be processed, the tokenizer is the function to go to. But what does the tokenization do? Well, first the function will segment the text into words, punctuation, and other characters. Then it will do checks on the substrings until they can't be split anymore. SpaCy, its basic pipeline, has a tagger component together with a parser component as the next in line. It assigns part of speech text, such as verb or noun, to the tokens. It also will check existing models for dependencies between the tokens. After the tagger and parser, there's something called the NAR, or Named Entity Recognizer. This component will detect and label the real-world entities. Now I would like to give the floor to Michael for deeper analysis.
Thanks, Thais. Okay, let's move on to a quick overview about technical debt in SpaCy. As you might expect from any up-to-date software project, SpaCy uses continuous integration to avoid regressions. Therefore, tests are run on all supported platforms: Windows, Linux, and macOS. After looking at the test coverage of PyTest, we were a bit surprised though. In this figure you can see the modules of SpaCy. The area represents the size of the module, the color the test coverage. It's nice to see that the architecturally important pipeline at the bottom is covered well. However, there is still room for improvement in other components. We continued with a deeper analysis using the tools Sonar and Secret. SonarCube was most helpful for us, and we were able to find 7 bugs. And yes, we fixed one of them. Other suggestions by the tools are mostly about code duplications. Duplications in the language component. It's pretty obvious for us humans that some of the supported languages share similar rules. The last slide from me is about GitHub issues over time. You can see when the maintainers go through the list of all issues, and you can also see that they try to close all issues for every major release.
Hey Nikhil, you can extend from here.
Now let's take a look at SpaCy's extensions and what it means for its architecture. Around the time SpaCy 2.0 was in alpha in 2017, it made a big architectural decision. SpaCy decided that its focus was on core functionality and performance of its pipeline. It decided that users who want to implement very specific applications should do so through the extensions or plugin component architecture that SpaCy was building. How did they do this? They standardized the structure of each component in the pipeline. This allowed users to create their own pipelines with custom components. Users could then make their own components free for anyone to use. We already saw what the basic SpaCy pipeline looks like. It's mostly static with core NLP elements. It looks quite boring. This is non-extensible unless you dig into SpaCy internals. With extensions, we can change the order of pipeline elements, replace components with other use case specific ones, or even remove parts of the pipeline altogether. By standardizing the pipeline and how elements plug in and modify attributes, SpaCy has created a possibility of a whole ecosystem of independent products around it. These products plug into existing architecture and enhance it. They call it the SpaCy universe. This allows SpaCy to innovate more on its core architecture and make more efficient uh, decisions while leaving specific implementations to other developers. Now I'll talk about our contributions to SpaCy. How did we do? We found that making pull requests to SpaCy is quite challenging because of the swarm of contributors who pick up issues very quickly. We did manage to make 3 pull requests though and raise one significant issue. I would like to highlight one of them. SpaCy doesn't currently have a roadmap on its website, GitHub page, or blog, and it marks important issues as pinned and puts all its feature ideas into one super long issue thread, which is really hard to navigate and keep a track of. So we raised an issue in this regard, and this is the proposed template. We looked at multiple open source repositories to put this together. It has 3 major sections: features being considered for a next major release, for next minor release, and long-term features where the details are quite sketchy. Each of these sections are divided into feature groups, and there are links to issues or pull requests. We think that this can directly impact the project and the rate at which features are being developed. Analyzing the SpaCy architecture was an enriching experience. We understood its components and how they fit together. We understood design decisions that were taken and how they impacted the product. We also developed familiarity with software analysis tools like Sigrid and SonarCube. Lastly, we learned how to work together as a team, most crucially in this last leg of the course where we've been physically distanced. Thank you for your time, and now we will take questions.